how many you can solve. Problem 1. The integral from 2 to 4 of the square root of x all over the square root of 6 minus x plus the square root of x. Problem 2. The integral from 0 to pi over 2 of the square root of sine of x all over the square root of sine of x plus the square root of cosine of x. Problem 3. The integral from the cube root of log of 3 to the cube root of the log of 4. The numerator is x squared multiplied by the sine of x cubed, and the denominator is the sine of x cubed plus the sine of the quantity log of 12 minus x cubed. These are all tricky problems. Pause the video if you'd like to give them a try, and when you're ready, keep watching to learn how to solve these problems in seconds. There's an incredible technique to solve all of these problems quickly. The integral from a to b of f of x all over f of a plus b minus x plus f of x is equal to b minus a all over 2. I learned about this on the YouTube channel Vedantu JEE. The proof is at the end of the video, and we're going to assume things like the function f is well defined from the interval a to b. But on the exam, you're going to get normal functions, so you can go ahead and apply this formula. So let's use this formula to solve the problems. Let's consider this first integral. Let's write f of x is equal to the square root of x. This is there in the numerator, and it's also there in the denominator. Now square root of 6 minus x will exactly be equal to f of a plus b minus x. This integral therefore follows this formula exactly, and we can then evaluate it as b minus a over 2. So this answer will be equal to 4 minus 2 all over 2. And the answer is 1. Incredible! We solved this complicated integral very simply using this formula. Let's consider this next integral. It again fits this formula, but it's a little bit trickier to see. Let's write f of x is equal to the square root of sine of x. We have that in the numerator and the denominator. What about the square root of cosine of x? Well, if you think about it, this is exactly equal to f of pi over 2 minus x. So we again fit this template, and we can evaluate this integral as b minus a over 2. So it'll be equal to pi over 2 minus 0 all over 2, and this simplifies to be pi over 4. Incredible! We solved another tricky integral with this formula. Now, what about this final integral? We can't apply the formula right away. We'll do a substitution. Let's write u is equal to x cubed. Du will be 3x squared dx. We divide both sides by 3 to get du over 3 is equal to x squared dx. So we can substitute in for x squared dx, du over 3. We then factor this 1/3 out of the integral. Now, let's do this substitution u is equal to x cubed. It'll simplify the limits of integration and the arguments of the functions. We're pretty much ready to apply the formula, but we just need one more observation. If f of u is equal to sine of u, then f of a plus b minus u is equal to sine of log of 3 plus log of 4 minus u. We can simplify this because log of 3 plus log of 4 is equal to log of 3 times 4, which is equal to log of 12. The integral therefore exactly fits our formula. We can evaluate the integral part using b minus a over 2. So the integral will be log of 4 minus log of 3 all over 2, which simplifies to be log of 4 over 3 all over 2. And now we need to remember to multiply this by 1/3. So the final answer will be 1/6 multiplied by the log of 4/3. And we've solved this incredibly complicated integral very easily. So now we want to do a quick proof of why this formula is true. Let's suppose that this integral is equal to I. We'll do a substitution that u is equal to a plus b minus x. Du will equal negative dx, so the integral becomes the following. Again, this will be equal to I because we've done a change of variables. Notice the limits of integration have flipped. We'll flip them back and that'll cancel out with this negative. Now, notice that we have the variable u. This is a dummy variable and we'll replace it with the variable x. So we have two different integrals that are equal to I. Let's add these up together. The result will be 2i, and on the left-hand side, it'll be the sum of these functions going from a to b. Well, the sum of these functions will exactly cancel out. This is equal to 1. So we have the integral of 1 from a to b, and that will be equal to b minus a. So I is equal to b minus a over 2, and that's exactly what we wanted to prove, that this formula is equal to b minus a over 2. And we proved it. Remember this technique and you'll solve many integrals in seconds. Thanks for watching and for making Mind Your Decisions one of the best channels on YouTube. Thanks for watching and thanks for your support.